So let's start another fractional function. So this is to give you another idea. Remember step 1 in behavior. In behavior. Now, as you can imagine, this is going to be type 2, as it was indicated by the title of your little slides. So if the degree, oops, sorry, we're using n for degree. Keep going back and forth. Okay, so the degree of the numerator and the degree, did it again, and the degree of the denominator. The degree of the numerator is 2. The degree of the denominator is 2. So since they are equal, this is type 2. So that means that y is equal to the ratio of the lead coefficients. So in this case, 2 over 1. So let's be consistent. Let's make our 2. Our horizontal asymptote now is at y equals 2. All right. Everything else stays the same. Rinse, wash, repeat. So step 2, that the denominator equal to 0, solve. So x squared minus 2x minus 15 equals 0. Well, what multiplies to get 15, and difference is 2, 5, and 3, right? And we need a negative, so we've got to go to the negative with the big number. So that means we have we have vertical asymptotes at x equals -3 and x equals 5. Negative 1, 2, 3. Oh, that's for the blue. X equals -3, and at 1, 2, 3, 4, 5. X equals 5. All right, so step 3, changing my pen. Whoa, drop my pen. Try that again. Black. Step 3, set the numerator equal to 0 and solve. Wow, this is really not working with the pen very well. Well, you can understand what I'm saying because I'm speaking about it. All right, so we've got 2x squared minus 5x minus 3 equals 0. Now we can factor this because we have a 2 and a 1. Since 2 is a prime number, it's always going to be like this, right? And we also know this only has one possibility, 3 and 1. Since we want to get 5, we're going to put the 3 with the 2 and the 1 over here. Now we need a negative, so we need a negative 6x plus 1x gives me 5x. So I get x equals -1/2 and x equals 3. There are 2 x-intercepts. So we have an x-intercept at x equals 1, 2, 3, and -1/2. Okay. Step 4. X equal to 0. Solve for y. So this is the nice one where we just get to say y equals the constant divided by the other constant. So y equals 1/5. So we put that guy in there. Somewhere around here, right? Okay. Step 5. our sign chart, right? So, numbers that we care about. We care about when x equals negative 3, when x equals negative 1/2, when x equals 3, and when x equals 5. Our four factors then are x plus 3, x minus 5, x2, x 1, 2, plus 1, and x minus 3. We said x plus 3 equal to 0, we get negative 3. To the left is negative, to the right is positive. Alright, x minus 5, we set that equal to 0, we get 5. To the left is negative, to the right is positive. 2x plus 1, set that equal to 0, we get negative 1/2. To the left is negative, to the right is positive. And the last one, of course, x minus 3, set it equal to 0, we get 3. To the left is negative, to the right is positive. Alright, so 4 negatives makes a positive. 3 negatives makes a negative. 2 negatives, positive. 1 negative, negative. No negatives, positive. So, when our function is less than negative 3, our function is positive. Up here. Let's make this another color. How about red? So our function is positive up here. Alright. Between negative 3 and negative 1/2, our function is negative. So it's going to go down like this. Between negative 1/2 and 3, our function is positive. So between negative 1/2 and 3, our function is positive. Between 3 and 5, our function is negative. And when our function is, when x is greater than 5, our function is positive. So here's our example of a type 2 rational function.